Okay, in today's lesson, we're going to look at a lot of vocabulary about circles. Some of it we're going to use today, and some of it in the near future. And mostly what we're going to look at is inscribed angles. So, some facts about circles. I believe we all know all circles are similar and have an angle measurement of 360 degrees. A portion of a circle's circumference is called the arc. The measurement of a semicircle is half of a circle, 180. Arcs are named by endpoints. The semicircle in the following diagram can be named arc AB. So you go from one endpoint to another, and that's how you name it. There's also something called a major arc. So basically, I'm just going to abbreviate everything this says. Arc AC would be this arc, the minor arc. But if you wanted this bigger part of the circle, you could, even though it starts with A and ends with C as well, you would name it ABC. So arc ABC. That's basically what I just said there. Let's see, two arcs of the same circle or of congruent circles are called congruent arcs if they have the same angle measurement. Let's see, the angle measurement of an arc is determined by its central angle. The central angle of a circle is an angle with its vertex at the center. That's what we're going to look at next week. A chord. A chord is a segment. Let's see, chord. A chord is a segment whose endpoint lie on the circumference of the circle. So this would be chord AC, and that would be chord BC. An inscribed angle of a circle is an angle formed by two chords whose vertex is on the circle. So this would be an inscribed angle because basically its vertex is on the circle. Okay, a couple basic notations about circles. Name the circle. So I would call this circle E. That's the symbol for circle, just a circle with a dot in it. Name a radius. There's a lot of radii in here. I don't know, I'll go with this one. Segment EB. I usually name I could say BE, but I usually name it from the inside out. Name a chord. How about this one? Let's go. Here's a chord, AD. Segment AD is a chord. Name a diameter. It looks like I have two of them here. I'll go with this one since I didn't use this yet. AC is a diameter. If AC equals 18, find EC. So let's erase all this. Let's see. If this whole thing is 18, what's EC? Well, so the diameter is 18, so EC is just the radius, which is half the diameter, so 9. If DE is 3, so this radius is 3, what's AE? Well, they're both radii, so AE would also be 3. Okay, here's what we're doing today, really. If an angle is inscribed inside a circle, so over to the right, angle 1 is an inscribed angle. Then the measure of the angle equals 1/2 of the measure of its intercepted arc. So what that is saying is, I'm just going to make up some numbers here. Let's just say that this arc is 100 degrees, then this inscribed angle is half of that, which is 50 degrees. Okay? So, using that, let's go through some of these. Find each measure. So letter A, angle P. Oh boy, it looks like the P got cut off. It's supposed to be right there. Okay, so angle P is an inscribed angle, and it's opposite the arc of 70 degrees, so it's half of 70, which is 35. Arc, so this is arc PO. Arc PO is, let's change some colors here. arc PO is this arc. Now, this arc is going to be double that of the 56 because the arc is always double the angle, or the angle is always half of the arc. So if I double 56, what is that? 112. So it's pretty easy. You just have to remember that the arc is double this inscribed angle, okay? And if you just use what you know about angles, you know, you can kind of estimate. For example, up here, if this is 70 degrees, well, I know this isn't double that because that's not 140, so it must be half of it. So just kind of using your intuition should help. Okay, this is arc CF. Where am I? Over here. Arc CF. Oh boy, now I got a problem here. Got a lot of stuff going on. Oh, okay. So this arc is opposite this inscribed angle, so it will be double that 40 degrees, which is 80 degrees. And last but not least, the measure of angle C. Let's see, here's angle C. And this is opposite the arc 98, therefore it's half of 98, which is 49 degrees. Okay, so remember, the inscribed angle is half of the arc. Let's see, vertical angles. Vertical angles are when two lines intersect and they're opposite each other. These two angles are congruent, which means they have the same degree. Let's just say this is 50 degrees, and then this would also be 50 degrees, okay? So, find the value of each variable. Got a lot of stuff going on here. I just like writing a bunch of stuff down and hoping for the best. Let's see, I'll start with what I see B here. B is an inscribed angle across from 104 degrees. Therefore, that's 54 degrees. Oh, I'm sorry, 52 degrees, right? Half 50, 104, 52. Okay. Angle A is opposite or across from this 70 degree arc. Therefore, angle A is 35 degrees. Now, how am I going to find the measure of angle C? Well, here we go. If you look, I have a triangle here, and I know two of the measures of the angles in this triangle. So to find the third, I could just do 360 minus 52 minus 35. Let's see if I have my calculator up. I don't. So let me go back, bring this up. What did I have? 360 minus 52 minus 35, and I get 273. Oh, I'm sorry. Oh boy, what am I doing? It's 180 degrees. I was getting mixed up with circles and triangles. It's 180 minus 52 minus 35. That makes a lot more sense. So I will call that, it is 93 degrees. So this angle is 93 degrees. So that means C is also 93 degrees. So I guess I'm going to say A is 35 degrees, red. B is 52 degrees, and C is 93 degrees. Okay, so pretty simple. You just have to keep it straight that inscribed angles are half of the arc that they subtend. And that is it for today. Your assignment will follow. Thanks. Have a great day.